but I think I loaded it on YouTube first. Valor's mom actually had the idea because I was thinking about just upgrading Zoom again. She was asking if it was possible that we could have all the videos like permanently saved from here on out. So I was thinking about just seeing how much it costs to upgrade Zoom again. And she suggested just uploading them to my YouTube channel, and checked into it, and it looks like it's not going to be a big deal. So I tried the first one. This is probably a month-old recording now. And so I've made it a private, it's a private channel. I've sent you guys and the Pierces email invites. I have never done this before. I'm totally a taker and not a giver when it comes to YouTube. So I've never messed with this side of YouTube before. So if all goes well, the video is currently, it says it's processing. Who knows? So I can't view it yet from YouTube. I can view it still on my computer the way it came off of Zoom, but I cannot yet view it over YouTube. So I'll be checking back, and we'll just see how this works. If this turns out to be a possibility, we'll go with it. If not, if it's just too much rigmarole, then of course there's always the option of upgrading Zoom again and giving a little bit more cloud storage. Because I think Mrs. Pierce is right that it would be really good now that we've hit the real intense part of the course. It would be really good if those recordings didn't have to disappear, even though I always delete about a month behind where we are currently learning. It's still, for chapter 6, for example, that if that's going to involve like deleting part of chapter 6 because it's so long of a chapter, it's got so much in it. So that's where we are. That's what we're that's what I'm working on. So you see some extra emails coming your way from me. That's what I'm doing. I'm just trying to make everything accessible to the people that I want it accessible to, and to no one else. So we'll see. Okay, the goal for today, we really only have 2 goals for today. One is to just a little bit more practice in 6.5. You never have too much practice in 6.5 because it's the foundation of everything else. And then we're going to start 6.6. And I wanted to put a warning here because it's not unusual for me to go out of order in a section, and the order that I teach things will differ from the order that the book lays it out for you. 6.6 might be the most extreme example of that. So I always try to warn you in case you are following along the book, or in case over a weekend you grab the textbook just to get some extra, see their perspective, to look at some extra problems. Beware of 6.6. My order, the order that I teach you things, is completely different than the order that they teach you things. In my opinion, they put what should probably be your go-to factoring method for 6.6, they put it last, and they throw all this other stuff ahead of it, and it really just is a mess to me. I really like this book, but I've never seen a book do it like this. I've never seen a book do it this badly. So we're going to learn what we learn in 6.6 can in one sense be the only 6.6 method you need. Now, as always, I like to show you all the options. Everything else is like a secondary optional shortcut. And some of these optional shortcuts are only good once you've mastered the basics. What I'm teaching you right now are the basics. The book, for some reason, flips that order, and they teach you the shortcuts first. And in some cases, that is just beyond confusing, and it can slow down. Because I say shortcut, it only becomes a shortcut after you've worked like 100 of these. So what I usually tell people is put in the time to learn the long way first. And then as you progress through math, if you have to take more math classes, if you go to college and there's math classes there, you might hit a point where you just feel like the old way is slowing you down, and that's a sign that you're ready for a shortcut. So just kind of bear that in mind. I'm not sure why the book does what it does, but we won't worry about it. Okay, so while we're waiting on Valor, we can go ahead and practice a little bit of 6.5 because what I want to do, we don't know a whole lot of factoring techniques still yet at this point. So this is a perfect time for me to just throw a problem out there with these instructions. So if I said to factor this problem, and I'm not giving you any hint as to how I want you to factor it, but bear in mind that you only have a couple of, depending how we count, we either have one or two, I would say two, just to keep everything straight. We either have one or two factoring methods at our disposal. And this, I should put, this is from 6.5, not a homework problem, but kind of around there from problems I would have given you like a week ago. Okay. So look at this problem and then take a crack at factoring it and just see what you get. So no clues coming from me, just know that it's something that we've done in 6.5 before.
Oh, I remember that. I think this was just last Tuesday when there was only 3 terms. We broke the terms up.
Okay, that
to make more.
Pretend that breaking the terms up and all that, that's actually, that was my preview of 6.6. So don't worry about having to do that. This is like from our very first day discussing factoring, which could have been like a week and a half ago even. This is before we learned about the 4-term factoring. So there's not a lot you can do to this. There's only 2 terms, so there's not a lot you can do to that. But there is something. It is absolutely factorable. And Valor, I see you're just joining us. That's going to confuse me. I see Valor's face and it says Ridge at the.
That's for my brother when he goes to do his other classes.
Not a problem. It's just, we'll see whether I'm more like a visual person or like a reading person as to what I call you throughout the class. All we're doing right here, Valor, is we are practicing some 6.5 factoring. So I've picked a problem with no clue as to how to factor it. And everyone's looking at this and seeing if they can figure out how can we factor that without being told any details, basically.
Okay, so I found that in some earlier notes that what we had done when there was only 2 terms was you found the greatest common factor of both of them.
That's great.
And then you divide it out.
Yes. That is what you should do, and that's all you should do in this problem. So see if you can figure out what that GCF coming out would look like.
Ma'am, would
Yeah.
you try to factor 12 and 3?
Yeah, from what Sarah was saying a minute ago, we are finding the GCF and then dividing it out. So yeah, you absolutely have to involve the 12 and the 3. You're looking for the biggest thing that can divide into both 12b to the 4th and 3b squared. And so that means you kind of have to take that in pieces. Your GCF in this case will likely have a number piece, meaning something that divides into 12 and 3. And then it will have a b to some power piece, basically. So, and whatever that is, we want GCF out front, and then the leftovers. That's kind of the format we're going for, yeah.
Okay, so I think I have the answer.
Okay, let's see it.
I think it's 3b to the second, and then in parentheses, 4 to the second plus 1.
3b to the second is definitely right, yeah, for the GCF, and then, yeah, 4b to the second plus 1. Yeah, that is correct. Great. So the 3 is the largest number that divides into both 3 itself and 12. So it's nice, the GCF that you are looking for is actually sitting right there in front of you. And then in terms of the B's, remember that we always incorporate the smallest power of any variable that we can find. Since if there are 2 B's, well, I should say here in this term, if there are 4 B's, that definitely includes there being 2 B's. So B squared automatically smallest power drops straight down into that GCF. So good, yeah, that is the factored form. And so this was an exercise, again, the directions just said to factor with no clues. And we always start any factoring problem. So that's going to be from 6.5, which we've just kind of finished, 6.6, 6.7, I think even a little bit of 6.8. So any factoring problem, no matter how many terms are sitting there to be factored, you always start by looking for an overall GCF. And we found one here, and in this case, that's it. So sometimes that's the end of the problem. So let's try one more that is kind of like that as we work through a little bit of a review. So directions say to factor, no other information given. This one, a little bit harder. This one was actually included in the homework that I gave out a week ago. Yeah, it was a week ago. So I think it was at least a week ago. And this is 6.5, number 39. So odd numbered, I gave it as homework. Okay. See what you can do with factoring a GCF out of this one, because, you know, from what we just discussed, that's the only option. If we can't do that, we can't do anything with this problem.
Okay, I think I got it.
Okay.
Is it 4xy parentheses 5xy plus 4xy to the second?
That is close. I'm just going to add an extra piece of information. The 4xy part is correct, and it's not, the direction you're going is not mathematically wrong at all. It's just, if we've got something that starts off with a negative term, they just always have us pull that negative down as part of it. So even though technically a negative could never be the greatest common factor, originally we just talked about, well, it looks cleaner, but when we got into the factor by grouping, we found out there actually is a purpose to pulling out that negative. So when it comes out, you're going to have a 5. You took one of the x's out as part of the GCF, and you took the only existing y out as part of the GCF. So that term is done. And then if we pull the negative out, that means we change the signs of both terms. And we've got another 4. We pulled that x out as part of our GCF, it's gone. And then from the 3 y's that were there originally, we pulled out 1. So there's 2 y's left. So this is a tricky one because there are x's and y's and also numbers. And also there's that leading negative. So I'm going to put a note in here. That's kind of why I was picking this problem. If the first term in whatever little cluster of terms you happen to be factoring, we just include that. Include the negative sign in the GCF. Basically, so when you get to the factor by grouping, you'll kind of be able to handle that part of it better. So there was our final answer. Okay. And speaking of factor by grouping, let me pull one from the group of homework stuff that I gave you guys last time.
Miss Savannah,
Yeah,
when are we having the 6.5 test?
I don't know. I'm not making, well, it'll be a chapter 6 test. I am not making any plans on that until I see how long it takes us to get through 6.6. 6.7 is a quick section, but then 6.8 is large again. And they also inserted a little review section. And honestly, I think it would be really good if we just took a class period or most of a class period and worked that review together, because by that point we will have accumulated so many different types of factoring that we want to kind of pause on that and figure it out. So I don't know yet. We've got November, obviously, we've got a week-long Thanksgiving break in here. So I'm kind of weighing on the one hand, it'd be great to just knock chapter 6 completely out before Thanksgiving so there's not a gap. On the other hand, I don't want to rush chapter 6 even a little bit. So I'm kind of weighing, again, I'm kind of weighing my options. Chapter 6 is so long that I will not be testing you on all of it. Remember in the early stages, it was like, here's what a polynomial is. Now we're going to add them. Now we're going to subtract them. Now we're going to multiply them. And then those exponent rules. Some of the exponent rules need to be on the test, but a lot of them you get just as part of your factoring. So I really am going to think about anything I can do to make this test really focus. I need it to focus on the factoring. It is possible, I'm thinking about giving you guys, this sounds ridiculous, but a take-home section. Everything you do is at home. But what I mean by take-home is maybe some of those early sections of chapter 6, I will let you do open book, open notes, because that's, if I were teaching this in a classroom, I would tell the kids, take home the test, you can take it home, look at your book or whatever, and what you do in class is sacred, you can't look at anything. So I may split chapter 6 in 2 and let the early sections be like a take-home type of thing, and then just have the ones where you have to close all of your resources, let that just be the factoring part. So I'm thinking all this through, one eye on the calendar, one eye on what we actually have done in class. So sorry, long and involved answer. Basically, I don't know, but there's a very good reason why I don't know. So I will update you as we progress. And definitely, what I definitely don't want to do is send anybody home with I'm sending you home with anything over Thanksgiving, that's for sure. So if we do have that gap in there, I will make sure that we have significant review on the other side of the gap before we finish off the chapter. Okay, so this is number 63. So this was, 53. This was one of the extra 4 homework problems that I gave you guys at the end of class on Tuesday. So directions, again, just factor, but because there's 4 terms, probably a huge clue as to how you should factor this. So everybody give this a shot. And as before, if you get all the way through and you feel good about it, let me know. If you only get part of the way through and you got a question, again, we can talk about it at any stage. So.
Okay, so I think I've got it. So
Okay.
my final answer was 6x plus 1 in one parentheses, and the other parentheses was 2y plus 3.
That's great. Let me write that down, and then I'll add in notes for the sake of when you potentially look back at these. So yeah, if you split the problem in half, you've got a GCF for the first two terms that's more complicated. You've got a 6 in there because that's the biggest number that divides into 12 and into 18. You've got x to the first because both the terms have an x to the first, so you don't have to worry about what's the smallest power of x. There's a tie, it's obviously x to the first. And then that's it, because the y appears in one of your two terms, but not in the other, so there's no way it can be common. Okay, so there's your first GCF, and then this one is the one where it gets slightly tricky, because 2 and 3, there's nothing bigger than 1. This y to the first, well, there's not another y, so you can't pull out a y. This is that time, you know, the exception to the rule, where we actually get to identify a GCF of 1, and it's significant. We actually have to write it down and deal with it. So our factored form starts out like this, 2y plus 3, and then as we factor out that 1, does not change the remaining 2y plus 3 at all. Okay. And then you had written the 6x plus 1 first, and then the 2y plus 3 at the end, which we talked about that absolutely doesn't matter. Okay. Great job. So there's just one more of these practice factoring that we're going to do. This was not in the homework problems that I gave you, but it's just slightly more advanced. And let me eyeball it real quick. Yeah, after what happened the other day, it's like I don't want to be caught off guard by these problems anymore. It looked harmless, just slightly more challenging. I just wanted to make sure it really was harmless. Okay, so directions again, factor this, which you see the 4 terms, and I'm going to can do my part here. Overall GCF, only 1, so we didn't have to do any overall GCF. Same thing here. Overall GCF, only 1. Okay, so see what you can do with this one. If you can get all the way through, that's great. If not, that's fine too, because there's negatives, so it's going to make it a little weirder.
Hey, Miss Savannah,
Yeah.
I think I have it, but I got kind of caught up all in the negatives. Is it, this isn't the final form, but I got negative x parentheses x to the second minus x end parentheses and then -2, and then another parentheses, x minus
X minus 1.
1, yeah.
Yeah, that part's good. That part's good. This part right here is the only part that needs a little bit of work. For one thing, you don't actually have to pull out a negative here. So this negative doesn't have to be there because the very first term, whoa, and that was a sloppy plus sign. The very first term in the two terms, if I split this in half, if I split it in half, okay, so these two terms, x cubed minus x squared, that's what you were trying to factor first. It's led off by a positive, so that means your GCF actually should be led off by a positive as well. Okay, and then when you pull out the x, yeah, absolutely, you would have x squared minus x, but notice that you actually haven't pulled out enough x's at that point. So when I look at, originally it was x cubed minus x squared, between 3 and 2, 2 is the smaller of those numbers. So I actually want to pull x squared out as part of my GCF, which means if I guess I'll erase that. If I do that, that leaves x minus 1 here. So once again, let me erase that. And then add for the notes, GCF is x squared, just by asking who's the tinier number here. And then you've got the part with the -2 spot on. Yeah, I pull out that -2, turns into x minus 1. That gets you the matching. Okay, so while it wasn't wrong to pull out x, it just wasn't enough. You know, we could do better. We could pull out more x's. So what you had done is pull out a common factor, and then we just went one step farther and pulled out the greatest common factor. So what you'd end up with is x squared minus 2 times x minus 1. I'm just checking to see if that's what I got in my notes here. Okay, so the weird thing about factor by grouping, because you're turning one really long problem into two, your really long problem, your original problem starts with a positive. So we're trained, you know, if it starts with a positive, that goes into your GCF. But then when you split it in half, it becomes two problems, and the second half, the second smaller problem within the larger one, is led by a negative. So you did a good job with that. That's about, I think, as tricky as these factor by groupings get in this book, which is great because in more advanced courses, I've seen them just get really carried away with it. So I just wanted to have us practice, do a little bit more of that, particularly because today is the day the 6.5 factor by grouping quiz is due. So if you haven't done that already, just a little bit of extra practice to get the juices flowing there, because unfortunately have to overlap. So you can go off and be working on that quiz this afternoon or something, but we do have to move forward a little bit into 6.6. And I previewed that on Tuesday. So factoring trinomials. Again, me going completely out of order here, sticking with what usually works for students, not with what the book thinks works for students. So a trinomial is a 3-term polynomial. So this is going to be another time when you count the number of terms that you see, and it gives you a clue as to how to factor it. The method here is to turn the trinomial into a 4-term polynomial. Again, no cute name for a 4-term polynomial. Then factor by grouping. So that's what I was talking about the other day, where it's, you already know the method at that point. You just have to figure out how to expand, because your original polynomial is not going to have enough terms for you to go into that method. So you have to kind of think. I've written down, because again, going out of the book's order here, I think I am going to rehash the same problem since we didn't really get a chance. It was at the end of class, and we didn't get a chance to look at it in too much detail. Okay, so factor, yeah, this was the one we had done. 2x squared plus 13x plus 6. And of course, I have to say it because one of these times it's going to be significant. Is there an overall GCF? That's another thing. This book starts getting into the overall GCF problems on top of everything else you're learning before they teach you the actual method that I'm teaching you. So they're just completely off their rocker in this section, in my opinion. So as always, nope, only one. That's good news for us. And what we want to do is expand 13x. And I should say too, before I say this, expand 13x, because I did not say this the other day. So I'm going to drag out another color here. We absolutely need the polynomial to be in descending order. So when we learned descending order a few sections back, it was mostly just a helpful thing. If you wrote your polynomial in descending order, it would be easier to add it, subtract it, multiply it to another polynomial. Now it becomes even more crucial. If your polynomial is not in descending order, you definitely want to make it. You want to rearrange so that it is. Otherwise, this method is just going to not work. So once you've got the polynomial to be in that order, let me rewrite that. So 2x squared plus 13x plus 6. Let's take that 13x and expand it out. So we want, since everything is positive, we want to turn this into like, and I'm going to pretend we don't know what's happening here. I'm going to pretend this is not in your notes. For example, what if we did like 11x plus 2x? We need a pair of like terms that add to be 13x. And there's a lot of them. And I'm just jumping in the middle here. I'm not even trying to be organized, because 11 or 13 can be 11 plus 2, 10 plus 3, and a ton of other things as well. 12 plus 1. And the key is picking the right pair of factors. You want to pick the right pair.
Miss Savannah?
Yeah.
Before you move on, I don't understand why you chose 13x. I know you tried to explain it, but like, why didn't you use 2x or 6? Why that one?
At this point, let's just go with it won't work. I know that's not a very satisfying answer, but the long and short of it is it won't work. If you were to expand this term to break it into two, you know, on Tuesday we talked, I kept calling it just the magic of the problem. The magic won't work unless we go by a very rigorous set of rules. And so one of those is that your polynomial better be in descending order. The next one is that that middle term, that x term, that needs to be the one that you expand, because we want this to work out in a way that for the rest of the problem, we can pick out, I guess, 3 GCFs. And we won't be able to pick out 3 GCFs unless we follow these steps. So I know that's kind of not a very satisfying answer, but basically, like, this method is like balanced on a razor's edge. You know, if you try to get creative and say, well, what will happen if I do this term instead, which nothing wrong with that, you know, just in a mathematical sense to kind of investigate it. But because we're trying to force this thing into a factor by grouping, they don't go into the theory behind it too much because that's just more than we need. But factor by grouping, those 4 terms specifically set up in a certain way. And so we have to be able to arrive at that very nice setup. And it won't work if we expand one of the other terms. So unfortunately, sorry, there's not a really clean cut, helpful answer I can give you at that stage. So just know that it's not arbitrary. I'm not picking the 13x just for the heck of it. There really is, it's kind of the key to the whole thing, because as it turns into two terms, one of those terms is going to end up being factored with the 2x squared. The other term is going to be end up factoring with the 6. So that's basically because it's in the middle. We'll say that. Pick the pair of, I should say the right or the correct pair of like terms that will, and I'm even going to put the magic part in the notes because it just feels that way, will magically turn this into factor by grouping. Okay. So remember that we talked about, even though we get kind of in the habit of seeing a 4-term polynomial and immediately factoring it using our new factor by grouping method, remember that realistically, we're not guaranteed to be able to factor it. Most polynomials in general are not factorable out there. The book just feeds us the ones that it has set up on purpose to come out nicely. So any pair of like terms here that add to be 13 will not work. If I picked 11 and 2, for example, that would not work. If I picked, 4 and 9, that would not work. So how do I know? Do I just have to try out every single pair? Well, no. We had talked on Tuesday just a little bit about how we know what's going to make the magic happen here. And that comes, again, assuming that we're in descending order here. If we take the 2 and the 6, so we want to take that first number and that last number, we want to multiply them together, always multiply. So we're trying to add to get the middle term, but what we do to the 2 and the 6 is always going to be multiplying. Okay, we multiply 2 and 6, and we get 12. Okay, this is going to be the key to the whole thing. That 12 is going to eventually relate back to what we're trying to do to our 13x as we split it apart. And the way that it does that is we need to break 12 down by multiplication. Okay, so again, big picture, we're trying to break 13x down by addition, but the 12 needs to be broken down by multiplication. So starting with the fact that any number can divide by 1, and I do this for my own sake so that I'll be organized. 12 is 1 times 12. It's 2 times 6. It's 3 times 4. Notice I'm going in order here in the left. 1, 2, 3. And then I do get to 4, but I notice that those two multiplications are equivalent. And that's my clue. If you go in this organized fashion, starting with 1, you know when to stop when you have repeating pairs of factors. So I will just pause right there. So I multiply my first number times my last number, and here I look for the pair of factors that add to be 13, or as the problems progress, whatever my middle number is, And if the problem is factorable, I'll be able to find a pair that add to be 13. If it's not factorable, I won't. So realistically, you know, if I were out there solving polynomials that model real world things, a lot of the times they just wouldn't factor. And we have ways of handling that we'll learn, I think in chapter 9 in this book. But for us back here, everything works out beautifully because 12, that very first pair of factors, from this list, I could say 1x, since I hadn't, 1x plus 12. If I'm listing all the ways that I can add two numbers to get 13, that's the two that end up happening because they share this characteristic there with the 12. So, and I'm going to give you kind of a process here, more of an algorithm, like work the steps in this order and you'll avoid confusion. We haven't really done that yet. So I can write 1x and 12x, but in the notes, just in case you're wondering, this will work if I put the 12 first. Again, if this is a factorable polynomial, that means there are a bunch of hidden GCFs in this problem. And I just have to dig them out. And if they're in there, then it will not matter whether 1 goes first or 12 goes first. Okay, so you start with 12x squared plus 13x plus 6. In the next step, you still have your 12x squared at the beginning. You still have your 6 at the end, but your 13 has been split apart. And of course, always pause, make sure you actually do have two numbers that add to be 13. And once you do, you can complete the problem. And this is what I did not do the other day for lack of time. Okay, so then you're back to what should look pretty familiar by now, factor by grouping. That's your goal in this whole thing, is just turn this problem back into something that we know how to handle. So if we split it in half, if everything is going to come out right, looks like between the x's, x to the first is the smaller of my two powers. And then here, I don't even have to worry about powers of x at all. I just take a 6 and just continue with the method. Not a 2, 6. You get those matching terms and parentheses that you need, and I think most of us have been enjoying writing the x plus 6 part first, so I'll keep to that. And at long last, you get to the end of the problem. And because it's factoring, you can check this. You can turn right around and distribute everything out and verify that you get 2x squared plus 13x plus 6. Okay, let me do a problem. I am going to have you guys practice at least one of these, hopefully two. We'll see how our time goes. I'm going to do one that shows the process that I use a little bit better. This is going to be practice 9. Now, I am leapfrogging all over and how I pick these practice problems because I want to start out only working problems that have positives in them. Basically, I don't want us to be doing negatives until you guys have had a chance to practice in a minute on positives. I also don't want a problem with an overall GCF. This is page 333. I forgot to write it. So this is what we're factoring. And as always, it's forming good habits for myself as well. Overall GCF, that 23 prevents the possibility of there being an overall GCF that is 1. Okay, now some people call this method, our book does not, Some people call this method the AC method. And the reason that we are sometimes prone to call it that is because a polynomial in descending order, the first number is sometimes called A, the second number is called B, and the third number is called C, just to keep track of them. So this method, I will put in the notes up here, factoring trinomials. This method is sometimes not in our book, but it's worth noting because if you go on to other classes, it may crop up. So sometimes called the AC method, other times not called that. So maybe the advantage of the way our book does it, they don't call it the AC method because they want you to just think of it as, really it's just factor by grouping. The factor by grouping is hiding a little bit and you have to pull it out, but it's in there. Okay, so the first thing you do, working this process, breaking it into as many steps as I can possibly think to break it into. Multiply A times C. So this is the part where maybe calling them A, B, and C is useful. Anyway, you multiply the first number by the last number as long as you've got something in descending order. So I've got 20 times 6. This is going to be a good one. This is big numbers here, so this will be practice for me. And I don't work these out ahead of time, partially just for time's sake, and also just so that you can see my brain have to go through the method as well without really knowing where I'm heading. Okay, so I multiply A times C, I get 120, and then I want to factor 120. That is, I want to break it apart into the list of factors. And at this stage, sometimes it's good just for practice, not even to try and think about which pair of factors I need. Just break it down. So starting at 1, this is going to be super fun because this is a big number. So I do have my calculator here to bail me out if I need. 4 times 30. 5. When I get to 7 for the first time in this particular problem, I have to skip. There is no 7 times anything whole number wise that will make 120. I think 8 will go in there though. So 1 carried 4, 8 times 5 is 40, yeah. 9, no. 10 will go in there. 11 will not go in there. When in doubt, feel free to grab the calculator. 11 will go in there, not evenly. 12 will go in there, but I already knew that. So notice here, I have that repetition of factors, so I can stop. Okay. Now step 3, after I've done all that work, find the pair of factors that will add to be my middle term. Now in the people that call this the AC method because they're labeling everything A, B, and C, they call the middle term or the number part of the middle term B. So for us, the middle term B or that number in the middle term is 23. So that is 23. And once you've done a bunch of these, or maybe as soon as you just figure out and feel comfortable enough with the method, you stop when you get there. As you list these factors, a lot of people start just kind of adding them as they go. They go, okay, well, 2 plus 60, that's not right. 3 plus 40, 4 plus 30. And then when they hit 8 and 15, because those two add to be 23, they know to stop. I went ahead and went the full length of the list, which in this case wasn't all that much longer anyway. The 10 and the 12 are all I needed. Okay, so you identify out of that list of factors, you identify the two that add together, and that is going to enable you to rewrite into a 4-term polynomial.
Wait, I thought we were looking for what factored out to be 120, not 23.
Yeah, we did. 120, 8 times 15 will multiply to be 120 because all of these numbers multiply to be 120. I wrote out a list of every.
Oh, I understand now. I'm sorry.
Yeah.
Okay.
Sorry, I can't I write so big that what I was doing disappears off the top of the screen. So it's easy to forget, where did these numbers come from? Yeah, so factoring 120, that long list was all the guys that make 120 by multiplication. And then 8 and 50, or 8 and 15, they do double duty. Not only do they multiply to be 120, they add to be 23. And that's the magic. If we can find that, we know this problem will factor by grouping. Okay, so down here, as we rewrite, and of course, I have no earthly clue. I was doing practice 9, that'll help. So practice 9, originally there was a 20x squared, and there was a plus 6, but instead of having a 23x, I've got an 8x or a 15x. And again, you could write that 15x plus 8x, and the method wouldn't care. So you rewrite into a 4-term polynomial, and you could even, because we are experienced at factor by grouping, you could go ahead and say, rewrite it and dive right into the factor by grouping. You don't even have to make that a separate piece. So some bigger numbers than we're used to, but nobody's negative, so that's good news. So GCF here, it looks like there's going to have to be a 4, since that's the largest number that can divide evenly into both 8 and 20. Looks like there's going to have to be an x to the first. And then for the remaining 2 terms, really nothing more dramatic than just a 3. Okay, so, and even though we've done a million of these factor by groupings, it's still worth noting when you get to the point that I'm at right now, especially if this is now in the context of 6.6. So the amount of things that we can mess up has expanded dramatically because we had to make this 4-term polynomial ourselves. We had to figure out what those 2 middle terms are. So pausing at any point to kind of glance back and just make sure that we're doing it okay, always a good idea. And if we have factored anything out, we can always kind of multiply it back through. Just make sure that we correctly identified and correctly divided out our GCFs. Seeing the 5x plus 2's matching is a really good clue that we're on the right track, but I have seen so many things in math problems. I have seen so many bizarre, I don't want to call them miraculous, but I've seen so many miraculous errors happen to where, let's say somebody messes up like a third of the way through the problem, and then they mess up again 2/3 of the way through the problem. I've seen so many times where magically their mistakes almost like cancel each other out and they end up getting to the right place in the end. And it's just bizarre and really aggravating to me as a teacher, because then I have to take off points for the method and give them credit for the final answer, and it just gets so discombobulated. So just check yourself as you go. These problems are getting longer and more involved. Okay, now that's the end. So let me scroll back up. Let's just review where we came from, because I am going to, before we attempt a problem with a negative in it, I am going to turn you guys loose on one of these. And with no expectation that you get all the way through. If you do, that's great. I just want to see, get as far as you can and we'll talk. So this problem, I checked it for an overall GCF, didn't have one. And it was nicely in descending order for us. So started with an x squared, dropped to an x to the first, and then to no x's at all. So we start by multiplying what they sometimes call A times C, first number times last number. We got 120. We had to factor 120 until we could find a pair of factors that also magically happened to add to be our middle number 23. So eventually, most of the way down that list, we came across 8 and 15. So they multiply to be 120, that's our clue, but what we really need them to do in the problem itself is add to be 23. And so as we make them add to be 23, we place that x next to them, because remember that even though we were focusing on 23, the number, 23 was part of a term that had an x attached. So if we're going to correctly complete the problem, we have to have those x's. That makes this a 4-term polynomial, which factors by grouping, as luck would have it. Out come a couple of GCFs. And the rest of the problem, there's nothing weird hiding in there. You get to the end, and it looks just like it did in 6.5. Okay, I think I had to delve into sort of the homework section. I didn't even go about picking. I'll send you an email with the homework, but I didn't even go about trying to pick problems for you guys. I figured I just need to see how far we get. And I also got to think really hard, because again, the order that they work problems is different, or the order that they teach you these problems is different than mine. So I'm going to have to exercise caution. Overall GCF. Nope. Only the number 1. All right, so using what we just did as a guide and recognizing that thankfully for you, the numbers will be smaller here. There's not going to be 120. Dive carefully into this problem and just see how far you get. Work until you're either finished or you're stuck. And let me know either way.
So I think I got the answer. Is it x plus 3 and then in the other parentheses 5x plus 1?
Writing that here, x plus 3, 5x plus 1. And normally I sit there and work them out, and then I got all distracted picking homework problems. So let me see if that's right. Okay, I'm going to write that off to the side here. If I multiply that out, I get 5x squared plus 1x plus 15x plus 3. Looks like I get a 16x. Yeah, so that looks right. So let me just fill in the steps here. Okay, so first step is 5 times 3 in our case, which is 15, and thankfully 15 is a lot smaller of a number. Okay. And not only is it smaller, but it's not an even number, it's an odd number. So there are way fewer possibilities for things to go into it. Yeah, that's it. And then the nice magic pair of factors that we need. 1 plus 15, that comes out to 16. I think that is actually our step 3. That checks out. So then we can expand and factor. Okay, so 5x squared. And then it ends with a plus 3, and I'm going to have, I just stick with the order that I see the terms here. 1x, 15x, split that apart, and GCF of x, GCF of 3. 5x plus 1, 5x plus 1, and there I am finally getting to what you had. Okay. Okay, very nice. Any questions about that before we introduce negatives? Unfortunately, if we don't introduce negatives today, because it's tempting to just be like, okay, let's end on a high point here and just cut the class at this stage. But if I don't introduce negatives, there's not a lot of stuff I can give you to practice. Because the book just, as soon as it introduces negatives into these type of problems, it just takes that and runs with it. So again, going dramatically out of order. On this page, practice 6. 4x squared plus 5x minus 6. Okay. As soon as a negative enters this problem, no matter where that negative is, no matter which term that negative, or possibly more than one negative belongs to, it automatically increases your workload. So a little bit of bad news there. Now, overall GCF, still managing to avoid those problems for now, only one. Okay, so here we go. We dive into our method. So 4 times -6 gives us -24. And as we factor -24, now you won't have to be quite this thorough as you get better at this, but think about the fact that when we have a negative number that we're factoring, I could have a bunch of factors that are like 1 times -24, 2 times -12. Basically, one of each pair has to be positive and one has to be negative. You can't like have 2 negatives or 2 positives, or they wouldn't multiply to give you a negative. 3 times -8, and I'm just going to say ... The other option is that you could have -1 times 24, -2 times +12, -3 times +8, ... And the clue to us knowing which of those lists we're going to end up picking from comes from whether our middle term is positive or negative. So notice here, we have a positive middle term. What that means is this list, the first list that I started writing down, is off limits. Because think about what's going to happen with this list. If I start adding each pair, 1 plus minus 24, 2 plus minus 12, the bigger number in each pair is negative, and so that's going to force the addition of each pair to come out negative, whereas over here, negative 1 plus 24, positive 5. That's good. Negative 2, positive 5, gosh. I'm just making it be what I want it to be there. That is positive 23. Negative 2 plus 12, that's positive 10. So this is the list that I need to focus on. So no, you do not have to write out every single possibility 2 times, just switching out the negatives. I'm going to kind of gently cross this list out. This list always adds to a negative. And there's no hope of that changing. Okay, the other list. I haven't gotten too far down that list because there's plenty of more things that could fit inside of 24. I haven't got too far down that list before I hit the pair of factors that add to be my positive 5. So that means I'm done. I can go ahead and proceed. And sometimes just to save yourself, if you're following my 4-step process here, that's step 3. If you do it off to the side there, as you're multiplying, go ahead and add. As you're multiplying, go ahead and add. That's your step 3. You've found the correct pair of factors. So that's going to let you expand. So it was 4x squared and minus 6. I get to leave those the way they were. And I'm going to add in negative 3x plus 8x. Okay. Again, it could be, even though we've introduced a negative, because of the magic of a factorable polynomial that has all of those hidden GCFs in it, it doesn't matter if you have 8x or negative 3x out front. Absolutely will not affect what happens next. Okay, so if I break this apart carefully here, looks like a GCF of x and a GCF of 2. Pretty nice and easy GCFs after all of that worrying that we had to do about negatives. Okay, let me see. That was practice problem 6. Practice problem 6, the final term was negative and the first 2 were positive. Yeah, let me give you guys, I had intended to work another one completely all the way through first, but as time goes, kind of runs out on us, I want you guys to have gotten your hands dirty with something that is enough like what we just did for x minus 3. Give that a stab. The numbers are bigger. There's a negative involved. So as always, I don't expect you to be getting to the end, but just see how far you get, either the end or the moment where you feel kind of inextricably stuck in the problem.
Okay, I think I've got the answer.
Okay.
I got 5x plus 3, and then in the other parentheses, 3x minus 1.
Yes, that is it. Five x plus 3, 3x minus 1. Okay, we are about out of time, and I was searching and searching through, because I want to be able to assign you some problems to practice, but there aren't a lot before I start running into too many differences. So these will be a couple that will be on the list, and I just wanted to point out what happens with the negatives when you've got problems like these. Because you start out, for example, problem 49, you would take your 3, you would take your -2, you would get -6. And then the problem that you just worked, we talked about how when you've got a negative that you're factoring, there's like 2 lists of factors. And because in this case, you're adding back to be a negative instead of the problem that we had worked. So that's a negative middle term. That changes everything. So this is the list that you want to go up. As a matter of fact, I just circled, not only is that the list, that's the pair of factors that you need there. So that's a hint for a problem that I will be sending out for homework via email. This over here, number 17, you start out with 2 times -12, and you get -24. No, sorry, 2 times -12. 2 times +12, I don't know where I'm seeing the negative. You get +24. This is potentially the trickiest one of all because it's not as obvious. You see that +24 and you want to dive right into, of course, a positive times a positive makes a positive, right? But notice that the middle term here is a negative. So that kind of forces you to remember that not only do 2 positives multiply to be a positive, but 2 negatives do as well. So this gets tricky. And I'll just go down the list here because I see my magic pair of factors. So if you're comparing list to list, you can completely ignore the first list. It's the second list. And not only that, but I have found, without too much effort, I found your pair of factors. So those 2 problems will occur in your homework. I just didn't want you to be caught off guard by them. I will send the homework out in a few minutes. I just need time to really, really make sure. So for those of you, I'm starting to see the quizzes trickle in, but you haven't turned it in already, that's due at some point today. Factor by grouping and homework and recording. I'm still going to be sending the recordings at this point since the goal is to have all the recordings available on YouTube, but as I said earlier, Valerie, I don't think you were here for that. I'm trying to get the recordings up on YouTube. Haven't quite figured it out. I sent a link to the video and to my channel to you guys. Try it out. I will definitely let you know when I feel confident that it's there. I'm going to have Ethan, my husband, look at it. We'll just kind of go from there. He will, I'm sure, make it work for me. So everybody have a good weekend. Let me know if you've got questions, and we'll see everybody on Tuesday.
Thank you for class.
Bye.
You're welcome.
Thank you so much.